Hello and welcome to Internet Capital Markets, the weekly show where we explore how financial systems are being rebuilt on the web. Each week, we sit down with the builders, investors, and institutional leaders shaping this transformation, from tokenized assets to decentralized finance, RWA, and everything in between. Today's show is brought to you by TrustBytes, smart treasury for Internet Capital Markets. Today, we are digging deep into one of the most important pieces of the whole blockchain ecosystem, oracles. And we have an absolute expert today from the fastest growing oracle in the space. Hello and welcome, Matt. We've actually met on a workshop during a Colosseum hackathon, and he's with RedStone now nearly 4 years and is leading go-to-market in BD. Welcome to the show, Matt.
Hey, Jeremy. Hey, everyone. Glad to be here.
Great. Maybe we start with that for everyone who doesn't know you yet. Could you introduce yourself and tell us the origin story of RedStone?
Sure. So the name is Matt. I lead the business development team at RedStone. Have been for the past almost 4 years now. The origin story is quite simple, actually. So RedStone is a child of an actual builder's need. So early in the days, that was 2016, 17, our founder, Jacob, used to take part in a lot of hackathons, ETH Global hackathons, and others as well. And he would build a lot of potential new DeFi primitives and products in general. And most of those products actually needed oracles in place to function. So that was around 2018, 2019, where he actually started really focusing on those products that did use oracles. And the only oracle usable at that time basically was Chainlink. So Jacob went to Chainlink and asked them a couple of times for some specific assets that they would need the oracles for to be able to be used in those products that he was building at hackathons. But the response was pretty much always the same. Chainlink would say that this is not really of interest to them, or it's not really doable, that kind of an oracle that Jacob would want. So this subset of oracles you could actually use was very, very limited back then. And Jacob decided to actually give it a try and maybe try to spin up an oracle on his own, just to serve the needs that he had during those hackathons. So that was the beginning. That was 2020, early 2021 when he started. And then he started pulling in some other people onto the company and to this effort. One of them being Marcin, so our COO and co-founder as well, who is basically the face of the company today. And that's how it all started.
These are always the best stories. If you have the need yourself and it doesn't exist, you just have to build it. And here we are today, the fastest growing oracle in the space. You're responsible for go-to-market, BD, growth at RedStone. Maybe for listeners coming from traditional finance or centralized finance backgrounds, how do you explain what an oracle actually does in the internet capital market space world?
So think about how a deal or trade happens in traditional finance. Usually there's two parties involved, and usually the price of that trade or of that deal is actually determined by a human. So there is an analyst with an open Bloomberg terminal, and they find the price of the underlying assets that need to be traded. And the settlement price comes basically from that Bloomberg terminal, is found by a person and delivered to a person, so the settlement can actually be reached, usually in the form of emails, PDFs, or other systems like this. But it's a human-to-human kind of an interaction. Now, this is obviously not possible when it comes to on-chain finance, which is autonomous, which is automatic, which has to run 24/7 with no human intervention, right? So that's what the oracle is here to do, is just to replace those humans that are in the whole process in traditional finance. And technically how this works is the oracle's job in most of the use cases is just go on the market, figure out what the price of settlement should be, gather this price from multiple different sources so that it's actually robust and trustworthy, and then deliver that settlement price to some specific place. And usually that place is a smart contract of the client protocol. So the price gets delivered, and then based on that price, an automatic decision can be made. For example, to liquidate a position on a lending market, to settle on a trade on a perpetual exchange, and all other types of financial decisions that you can have based on it. But in general, it's like the Bloomberg analyst, but in an automatic format and delivering the price not to humans, but actually to code, to smart contracts that are deployed already on chain.
Yeah, that's a very good way to explain it. And RedStone actually calls itself modular, gas optimized, and ultra low latency. What problem in Oracle design are you solving that? And you talked about Chainlink. What, for example, Chainlink and Perth next to not having the assets actually doesn't solve? Is it on demand? And maybe why is that important? Or is there another reason or design element?
There is quite to unpack behind the modular part here, but for us, this means different things to different people. If you go and talk with an L2 blockchain or an L1, they will give you a different definition. If you talk to somebody like Celestia, they will give you a different definition. For us, this modularity aspect means that the infrastructure that we've built is just built on top of many different components, many of which are redundant to each other for the sake of survivability of the whole network. But this also means that we have quite a lot of flexibility when it comes to adapting that infrastructure to different use cases. So specifically, also because it was built in like 2017 and 2018, but for example, when you look at Chainlink's infrastructure, it really is a pain for them to sort of adopt it to a new form of a VM, for example, a new chain that hasn't been really built in the past, because it was designed pretty much with a single chain in mind. And it's not surprising that was 2018, 2017. We have the privilege to be the second wave of infrastructure here in that specific niche, meaning we understand that you have to be able to adapt that infrastructure to different use cases, and specifically offer something that could be an end-to-end solution. So a good example here would be our implementation for Hyperliquid and for HIP-3 markets. So the builder deployed perpetuals. You can basically bring your own markets to Hyperliquid, to the perpetual exchange. In order to do that integration, this was a completely different integration than our standard chain or DApp integrations. But in order to do that, we had to basically repurpose some of the components that we already had going for different other integrations to be able to actually offer an end-to-end solution as the only Oracle to date on the market. So normally you would have to, as a deployer of some of those markets, you would have to kind of hatch together the Oracle and then the Hyperliquid part and kind of do the integration yourself, which is painful and basically dangerous, especially if you don't know exactly what you're doing. For us, it was quite easy to provide an end-to-end solution so that you as a builder can actually focus on the thing that you do best. So figuring out which markets to bring to the exchange, making sure the liquidity is there and taking part of your core business, as opposed to the tech part. The infrastructure is modular, meaning it's flexible, which just gives us this ability to really provide something that would close that use case end to end. It's just one of the examples, but it's definitely a big differentiator between us and the competitors. We are just willing to go way deeper into use cases that really make sense for us and provide something that would be just perfectly suited for that kind of a use case.
Yeah, and you're doing that very successfully. We often talk about capital markets moving on-chain, but data is kind of the missing piece or the bottleneck. Why do oracles become the data backbone of on-chain finance rather than a side module?
I think it's important to draw the line between a private network, a private blockchain, like an enterprise blockchain, and an open and permissionless network, because when it comes to the latter, that's exactly where oracles become what you've described, the backbone. When it comes to a private network, you don't really need that depth of the oracle infrastructure there, because the whole system is your own walled garden, and you, as the owner of that garden, basically decide what the settlement price is going to be between two parties trying to make some form of an exchange on that chain. Whereas if we are venturing out into the open and permissionless networks, and this, as we all know, has been happening for the past 12 to 18 months, everybody's now realized the benefits of those types of networks and the liquidity and the open market that comes with it. So then you actually need a trusted party that's going to be able to tell you with no doubt whatsoever on what the settlement price should be. So just imagine two banks trying to kind of do some business together, and trying to arrive at a settlement price in an automatic manner. Well, that's exactly what the Oracle has been built to do. But again, this really, really shines under the assumption that we are going into the open and permissionless future. If not, there is also a use for oracles on those more like closed loop systems, but it's definitely not as important as on those open and permissionless networks, because then the oracle is basically what makes or breaks the trade, which makes or breaks business models in some cases. And the accuracy of that oracle is also something that is just going to be of tremendous importance to everybody that would like to undertake any form of business on an open and permissionless network as well. We strongly believe that we as an industry are going into that direction. There is probably going to be certain use cases that make sense only in those little enclaves, and we are also open for business on that front. But the ground hypothesis, I believe, is quite strong that the open and permissionless networks will strongly require oracles to function.
That completely makes sense. A good sales guy would have answered, it depends. A great would have given us an explanation like you just did. So let's go a little bit back to the use cases you mentioned earlier and the competitive landscape. Now, Chainlink actually pioneered the push model and became the standard. RedStone takes a different approach, which is modular, push, pull, hybrid. And let's explain a little bit why this flexibility is so crucial for the next wave of DeFi.
So we do everything, basically all sorts of interfaces that you can think of when it comes to consuming the Oracle data. We basically provide it. The difference between a push and a pull model and a hybrid, it sounds big, but really it's all about just the last mile delivery of that data in most cases of Oracle systems. It is tremendously important because many different things can go wrong, and we've seen many different things go wrong with oracles just on that last mile delivery of that data. So when the data is already gathered from the market, it's already aggregated, it's packaged into data packages, and there's always things that can go wrong on that last mile delivery. Basically, the whole premise here is that with the push model, things are just the easiest for everybody who builds stuff on chain, because the price is already on chain. The price is already in a smart contract, meaning it's traceable, it's unquestionable. It's not the fact that you have to just take it somewhere from off chain and build kind of a circuit to be able to bring that price in. So it's a very clear situation. But the drawback of that obviously is gas costs. So anytime you want to update any form of logic on chain, you have to pay for it, and usually the older the chain, the more expensive it is. Or should I say, Ethereum mainnet is the outlier when it comes to actually being expensive as a chain for standard price feeds, right? Not the case anymore, but there is edge cases where you can still you still have to venture in those costs. If we are going into a very low latency scenario, then all of a sudden, not only just Ethereum mainnet is an expensive chain, but pretty much everything is to a degree, because pushing prices and updating the logic in a smart contract every couple of milliseconds, for example, this just compounds the costs, even if they are just fractions of the cent per each change of logic in that smart contract. Obviously, there's going to be thousands and thousands of them in a unit of time. So, in an ideal world, everything would be push model, because it's just like the easiest for everybody who would like to consume those price feeds. It's permissionless. Everybody on that chain can touch that price, query it and use it. But there is the second side of that equation, which is the gas costs. This is also why we offer so many different interfaces. And this stems from the fact that the infrastructure is modular, is flexible, and we are able to cater it to specific use cases. But in general, all of those different flavors of an Oracle interface cater to different use cases on this kind of a spectrum between the latency or frequency of updates and the costs of changing logic.
Yeah. Thank you for that. Now, in terms of oracles, you are not only the fastest growing, but actually the fastest. So RedStone actually claims under 1 millisecond latency. What types of protocols or trading systems actually benefit from such speed, and do we risk recreating high frequency finance on chain?
I think the design space just opens up under certain latency of updating the price on chain. Specifically, when you look at a simple financial primitive like a lending market, all of a sudden, under certain latency, you are able to really, really efficiently do partial liquidations, for example. Because of how fresh the price is, you can just bring the position on a lending market back to health by just having a little haircut on it, as opposed to just trying to take the whole position and sell it out on the market, either as a whole or in batches. Different standard lending markets have different opinions on how to do it well, but in general, the mechanism is you have to take that big position, for example, $10 million of collateral, and sell it on the market, which is going to have a lot of price impact, and it's going to make the market worse for everybody else that's involved. Needless to say, for the person that is, for the participants in that lending market, specifically the ones that have outstanding loans. Now, with high latency, you can change the design of something like a lending market, which historically did not need any form of low latency Oracle products. And then you can just have a different liquidation mechanism, or then you can have way tighter loan to value numbers and parameters, because the price is just so much fresher. You don't have to account for a couple dozens of bits for the additional buffer to make sure the protocol does not incur bad debt, because now the price is as fresh as it gets. It's basically real time, which means you can really, really crank up the capital efficiency of that market. And that, technically, business-wise, that means the money flows to you from competitive products because they earn more per each dollar on your protocol. This is also obvious for perpetual protocols. The fresher the price, the better the settlement price and capital efficiency as a whole of that system. So there is quite a lot to unlock, and I believe that builders on such systems like Monad or MegaETH, where we've launched or will be launching, as it is the case with MegaETH, our Vault product, so the fastest push Oracle ever, they are still kind of learning on how to use that most efficiently. But there's definitely a new design space here. And when it comes to replicating high frequency trading on chain, I think there's still quite a long way for us to go, for us as an industry, just because there's always some physical boundaries that you can't really cross by just having some distance between two nodes in a network, as opposed to just like servers being glued together in a basement in New York City, right? As it is the case with traditional finance. I think we still have to account for that, and a lot has been said about how to minimize that latency, but this is physics, this is speed of light as well.
Yeah.
So if that happens, that's actually good, I think, but I think I still have to kind of go quite a long way to really get to that level of low latency as some of those industries have currently.
Yeah, you can say we have a long way, or you can say we are at the beginning of it. We actually had a episode on HFT itself, where we digged into that. That's episode 8. So you operate actually on over 110 chains, both EVM and non-EVM. How do you maintain reliability across all those ecosystems with completely different assumptions? So Solana versus Arbitrum versus Sui versus Upchains and so on.
So tying it back to the flexibility aspect, the way to think about the infrastructure high level is that the prices that we then push on chain, they always live off chain first in this kind of a decentralized cloud, if you will. We call it the data distribution layer, but it's basically a service that's composed of many different redundant services to keep the prices alive, or the price packages alive. And from this decentralized cloud, those packages can be pushed to all sorts of different chains. Now, this is an important distinction because this is not the case, for example, for Chainlink. They don't really have that kind of a middle layer. So anytime they go to a new chain, they have to redeploy their node network, the Oracle node network. And that's what makes it so hard for them to actually to deploy on those new chains. For us, we have this middle layer, and this allows us to just optimize that last mile delivery of those data packages. So it's the same data that you can push on Ethereum mainnet, and you can push on Sui, and you can push on Canton in the Django language, which is completely exotic from our standpoint and in comparison to other blockchains. But it's the same data packages, basically, and the amount of code that you have to rewrite and the amount of code that you have to maintain specifically per blockchain is just minimized by like 3 orders of magnitude because of that kind of design choice that we've taken. So it is hard work because, as I said, many things can go wrong only on that last mile delivery of that data. So specifically, somebody, usually it's us taking care of maintaining the bots, pushing those prices on chain. This can be permissionless, everybody can do it, and some protocols do this themselves. But even maintaining a small piece of code like this requires a ton of DevOps resources and understanding what can go wrong, and what do we do if the chain stops, and what do we do if there is a big AWS outage, and what do we do if X, Y, and Z, right? That there's a whole list of edge cases that can happen. And running even that reliably is a hard job. But still, we are trying to make our job easier, not harder. So that's why we don't have to run the whole Oracle network on many different instances on different chains. It's just kept in separate compartments, and then they are optimized separately just to make sure that the survivability of all of them is just as high as possible.
Yeah, you just said that things could go wrong. So one classic one is, for example, that we see DeFi protocols actually collapsing because of Oracle manipulation. And one can also say that price integrity is actually more central for internet capital markets than TVL, IPY, or liquidity incentives. Why is that?
Yeah, that's the nature of the industry, because decisions are being taken on some input data in an automatic manner, right? So even if the data does not make sense whatsoever, even if it's 1,000 times higher than it should be, if you don't have the right logic implemented in your protocol, the decision is just going to be made, which means oftentimes a total collapse of the protocol, or at least quite a lot of bad debt. So this is the big responsibility that oracles have, to be able to predict things like this, and to be able to tell, okay, if the oracle prints a price like this for whatever reason, then this should, light all the red lights up, and potentially maybe this should, do something else with the oracle, such as keep the beat or stop updating, or detach a given data source that might be faulty, or or I don't know, ping the protocol, depending on the specific integration. But in general, you really have to think in the context of second and third order consequences of what happens if all of a sudden there is low liquidity in one of the data sources that the oracle uses. How does that actually influence the final protocol consuming that aggregated price at the end, right? So this is hard job, and really getting it right is very, very hard. There's different opinions on how people like to do it, but in general, I think it's fair to say that we have the best track record when it comes to keeping the price real and surviving of all the oracles, of all the major oracles so far. And that's specifically because so much thinking and real developer hours have gone into designing those edge cases, trying to find solutions for them, and responding in real time to strong market turmoil, for example, as we saw that during the 10th of 10th market drop down.
Okay, great. Thanks so much. We are actually at time to change to the next part, which is the quickfire. So I will give you one question and you have one word each to answer. So let's change gears a bit and see if you're ready for that. Great. Okay, so the most overrated Oracle narrative today.
Speed, I would say. It's still, for 99% of these cases, it's not as needed as people think.
Okay. And the most underrated data primitive.
Indexes, I think. This is kind of a giant that everybody sleeps on, but yeah, it will come. It will come as it did in traditional finance.
What is the most misunderstood risk in Oracle architecture today?
Survivability. So how hard actually it is to keep 100% uptime, not a 99.9% uptime. It really is a tough job to do.
Okay. Permissionless or permissioned?
Permissioned, I believe. Still, the Oracle's job is to curate the price feeds that you should have and the ones that you shouldn't, because of, for example, low liquidity. So, our clients trust us that we do a good job on that front, and that's why some of the parts of the infrastructure, such as allowing new asset issuers in, I believe should be permissioned.
Yeah. One word to describe the future of on-chain markets.
Abundant, I would say. Everything's coming on-chain, so there's going to be plenty of things to do and choose from.
Okay. Now, one sentence. How will internet capital markets look by 2030? And imagine, do we have trading automation, AI agents? How will agents use oracles?
Pretty much the same way as protocols do today, because today an oracle talks directly with the protocol. So tomorrow the oracle will talk directly with the agent. So it's machine to machine. Not much changes in my view.
Excellent. Thank you so much. Last but not least, how do people find you and who should we talk to next?
Sure, you can find me personally at my name and surname, so MATTGURBIEL at Twitter. I share quite a lot of the findings of our journey of building this company. You can also find the company handle at RedStone_DeFi. And yeah, when it comes to next guests, I believe probably some of the thinkers on the perpetual market side of things. I think this is coming still as very, very hot topic, not only because of Hyperliquid, also because of Ostium and other, I guess, attempts at the right trading infrastructure for different types of assets like commodities and equities and crypto native assets. So tremendously interesting space, I believe, and a ton of things to learn from those people.
I agree that that's a good direction to take. Well, thank you so much, Matt. Really great insights that we had today. Thank you for sharing those. If you enjoyed today's discussion, make sure to subscribe, rate, and share the show. It helps us to bring more conversations like this to you. This is Internet Capital Markets. Join us next week as we continue exploring how technology, capital, and human creativity converge to build the financial systems of tomorrow. Until then, stay curious, stay connected, and keep building the future of finance. Bye-bye.
Cheers. Thank you.